question that you're able to get it done on paper, but you don't know how to get it done in digital?
Yes, that's
Sorry.
exactly the question.
I think you were muted. Okay, now I get your question. Okay, so basically, let's say we wanted to implement that circuit that I just talked to you about, the 2013 video.
Yeah.
What you'd have to do is you can see my screen, can't you?
Yes, I can.
Okay, so I'm going in and I'm getting a D flip-flop. There's my D flip-flop.
Okay.
Now I've drawn a flip-flop. So all I need to do now is to put the next state logic in here and the previous logic in here. So as part of the project, I've given you a clock. So I'm selecting it, pressing Control-C, and then Control-V for paste. This will be my clock input that's going to cause my flip-flop to say clock it in. I have a D input into this flip-flop. That'll be the state, the next state. This is the Q output. And now I just need to add gates here. So stop me if I'm saying something that doesn't make sense to you, but so the example we just looked at was an AND gate, logic AND gate. So there's an AND gate, and you can actually make this AND gate a bit smaller if you want it. I'm sure you don't want to, but you can. There we go. And an OR gate. So an OR gate, insert components, logic, OR, and there we go. And I think the way that thing works, it all worked on that example was like that. Yeah. And then it ORed there was another flip-flop here. You can actually set this thing to contain 2 bits. That's a shortcut method of doing it if you want it. But let's not do that now, otherwise it's going to confuse you. Okay. So let's just make it 1 bit for now. And let's rather just have 2. So clicking it, Control-C and Control-V for pasting. And I'm going to use the same clock for both. And this also has a next state logic. And then this here goes all the way around, all the way around. Do you agree that this is the same as what we had on that slide?
Yes.
Okay, and then the input here will be W. And that's really it. So then you just have to do this. So this is the next state for the 1 bit, and the output goes to Z. And for the other bit, you do exactly the same. Does that almost answer your question? I'm not sure.
Yeah, it did. So then how do you see the final result from here?
I'm just going to stop recording. I think that's enough for now. Say again, yes?
Then okay.
There you go. Right, so a student has just asked me, how do you check whether this thing now works, what it does? And I've just said you connect the input here. So this is just an example. I'm just connecting an input into this state machine where this is my next state logic. The output logic will go here, but for the transmitter, there's virtually no output logic. The outputs go directly into where they need to go. And in this case, it's a 2-state machine or a 2-bit state machine. In your transmitter's case, it will be a 1-bit state machine. But anyway, to check whether it works, you press play, and then it simulates. And you can see the clock is going up and down, and serial stays high. And you can press buttons and go crazy on this now. If you want to run the tests, which look very similar to the tests that we will use to assess you, you go simulation, run tests, and that then runs all the tests. So you can't see it possibly now, but I've got flashing lights and stuff going on here on my screen, but you can see it's failed because my circuit has not been fully implemented or properly implemented yet. Does that answer your question?
Yes.